Imagine you're moving apartments and packing up a cardboard box. You know exactly how this works. The amount of stuff you can fit inside depends entirely on the three-dimensional space, the volume of that box. Now, imagine if the rules of geometry broke down. What if the amount of stuff you could pack had absolutely nothing to do with the interior volume and was entirely determined by the flat two-dimensional surface area of the cardboard walls? In the 1970s, physicists Jacob Bekenstein and Stephen Hawking realized that this exact counterintuitive scenario happens to be true. They discovered that all the information inside a black hole, every swallowed star, every trapped particle, doesn't scale with the dark three-dimensional volume inside. Instead, it is perfectly encoded on the two-dimensional surface area of its event horizon. At the absolute extremes of gravity, reality discards the concept of interior volume, storing all its physical data on a flat, enveloping surface. In 1997, a theoretical physicist named Juan Maldacena asked a spectacular question. He wondered if this strange quirk of black holes might apply to everything else. Maldacena formulated what is now called the ADS-CFT correspondence. It proposes a mathematical duality, a precise equivalence between two very different physical theories. According to his math, the entire three-dimensional universe you experience, every gravitational pull, every physical object, every thought running through your brain right now, might actually be encoded on an unimaginably distant two-dimensional boundary. How is it physically possible to experience the rich depth, distance, and gravity of our world if we are effectively a mathematical projection from a flat edge? If Maldacena's duality holds true, the visceral three-dimensional space we navigate every day is an illusion hiding a much flatter truth. To grasp how this works, we can look at a physical object that behaves the exact same way, a sheet of holographic film. If you hold up a piece of this film, it looks completely flat, but tilting it slightly under the right light reveals a fully realized three-dimensional object projecting outward into the space in front of it. The critical thing to understand about a hologram is that the flat film and the glowing projection are not two separate things in different places. They are the exact same physical reality, just described mathematically in two different ways. The image is the film, and the film is the image. Neither perspective is more real than the other. Our universe acts exactly like this film. Our deep reality and its flat boundary description are identical. We just happen to be experiencing the projection from the inside. But how exactly does a distant edge build the physical space we walk around in? The answer seems to lie in quantum entanglement, an invisible connection between particles that acts as the yarn weaving reality together. Think of the 2D boundary as an unraveled sweater. On that flat surface, physical distance doesn't exist, only particles and varying degrees of quantum correlation. Highly entangled particles project into our 3D bulk as physically close together. Weakly entangled particles project as far apart. Physical space is not an absolute given. The distance between you and the screen you're watching is a derived trait, an illusion assembled from microscopic correlations at the edge of the universe. This mathematical framework has allowed us to calculate everything from black hole entropy to the behavior of plasma with high precision, but it carries a massive, embarrassing catch. These equations only work in anti-de Sitter space, a theoretical negatively curved toy universe with a hard, defined edge where a two-dimensional boundary can live. But our actual universe is positively curved and accelerating outward, with no stable, defined edge to hold a holographic film. We are holding a map that has predicted physical phenomena with incredible accuracy, only to look up and realize it was drawn for the neighboring city, not the one we actually live in. This is the current crisis in quantum gravity. Our most rigorous mathematical model currently describes a universe that is not ours. This gap in the physics points toward a structural wall in human knowledge. If the universe is a hologram, where exactly is the conscious observer standing within it? We already know that deep inside the 3D projection, specifically past the event horizon of a black hole, the translation between the boundary and the interior breaks down entirely, blinding our equations. The mathematician Kurt Gödel demonstrated that these limitations are built into the structure of logic itself. Gödel proved that any formal system large enough to describe the universe will always contain true statements that it cannot prove from within itself. Reason cannot ultimately validate its own consistency. We are attempting to understand the holographic projector, but we are built entirely out of the projection. It is exactly like characters in a novel trying to analyze the chemical composition of the ink they are printed in.